Assalamualaikum to Dr. Amalina. My name is Nur Faradiba binti Ahmad, matric number 76071. Today I will explain about how I do the assignment for Miss Belen CO1. From the question given, we know that there are two reactions involved in this question, which is first, the hydration of ethylene into ethanol, and second, the ethanol undergo an indesired reaction to produce diethyl ether with the traces of water. And figure 1 shows the flow chart for this question. So from this flowchart, we know that there are three variables, unknown variable that we must find, and there are composition of effluent gas given in the question. To find the degree of freedom, we use atomic species balance. From the previous slide, as we can see in the flowchart, there are three unknown labeled variables that we must to find, which is the number of mole of the ethylene, the number of mole of the water, and the number of mole of the inert gas. And there are two atomic species balances involved that we use for the calculation part later, which is C and O. And there are one molecular balances independent non-reaction species, which is the inert gas. Then we get the 0 degree of freedom, which is the which is mean we can solve the question. First, for the calculation part, using atomic species balances, we can directly find the number of mole of the inert gas because the inert gas is non-reactive species, hence the input equal with the output. The composition of N2 per mole was multiplied by the total of effluent gas, and we get 11.3 mole of inert gas at the input side. To find the number of mole of ethylene, we can use C atomic balances. First, as we know, how the method to find the number of mole of the ethylene at the input side, the number of mole of ethylene at the input side, which is what we must to find, multiply by how many C in the ethylene, which is 2, and divide by 1 mole of ethylene involved in the reaction, equal to the number of mole of the ethylene at the output side, multiply by how many C and divide by how many ethylene involved in the reaction, plus the number of mole of ethanol, because ethanol also contain C in it, multiply by how many C in the ethanol, divide by how many mole of the ethanol involved in the reaction, which is 1, plus the number of mole of the ethyl ether at the output side, because the ethyl ether also contain C in it, divide how many mole of the ethyl ether involved in the reaction, and the number of mole of ethylene at the input side we get is 42.3 mole. The question, for your information, why I use 2 mole of C, because in the ethanol calculation I just use 1 mole of ethanol, So when I divide 2 and I divide 2 here or so, from 4C I divide 2, there are left with 2C. Therefore I use 2C. In this calculation, we get the number of mole of inert gas and the number of mole of the ethylene. From the previous calculation, we already get the number of mole of inert gas and the number of mole of the ethylene. So one thing left for we to find is the number of mole of the water at the input side. Now we use all atomic balances to find the number of mole of water at the input side. Same as how we find the number of mole of ethylene before, the number of mole of the water at the input side, which is what we must to find, multiply by how many O in the species and divide by how many mole of H2O involved in the reaction, equal with the number of mole of the water, which is H2O at the output side, multiply by how many O in the water and divide by how many mole of H2O involved in the reaction, plus with the number of mole of the ethanol at the output side, because ethanol also contains O in it, multiply by how many O in the ethanol, which is 1, divide by how many ethanol involved in the reaction, plus the number of mole of the ethyl ether, which also contain O in it, multiply by how many O in the ethyl ether, divide by how many mole of the ethyl ether involved in the reaction. Therefore, when we calculate all of this, we get the number of mole of water, 51.3 mole. Now, we get all of the variable that we want. So, we can find the total of mole feed, which is gas in, by adding all the unknown variable that we find. And we get the total gas in is 104.9 mole. For the summary of feed gas, we can find the composition, the percentage composition of this species with at the input side by dividing the number of mole of the species with the total of the feed gas. And for the ethylene, we get 40.32%, and for the water, we get 48.91%, and for the inert gas, we get 10.77%. From the question also asks we to find the percentage of conversion ethylene, fractional yield of ethylene, and also the selectivity. Firstly, to find the percentage of conversion, we know the formula is mole reacted was divided with mole feed multiplied by 100%. So the percentage of conversion ethylene is the number of mole of the ethylene at the output side, divide with the number of mole of the ethylene at the input side, input, multiply by 100%, and we get 88.42% of percentage conversion of ethylene. And next, to find the fractional yield of ethylene, the mole of desired product form was divided with the mole of reactant feed, which is also the number of mole of ethylene at the output was divided with the number of mole of ethylene at the input. So we get the fractional yield of ethylene is 0.884. And lastly, for the selectivity, for the formula to find the selectivity mole of desired product form, which is the ethylene, divided by mole of undesired product form, which is the water, ethanol, diethyl ether, and also the inert gas. And the selectivity, the number of mole of the ethylene was divided with the rest of number of mole undesired product that I mentioned before, and we get the 0.597 as the final answer. Okay, for question C, we were asked to to validate our answer using the extent of reaction method. So first thing to know when we are using extent of reaction method, in this question we have two reaction, and the first reaction we call as the extent of reaction 1, and the second reaction we call the extent of reaction 2. So this is the general formula before we doing calculation for extent of reactor method. So from the knowledge we have, when the species at the product site, we consider it as positive value, and when the species at the reactant site, we consider it as negative value. So same as question B, what we need to find is the number of mole of the ethylene first, and second the number of mole of the water, and third the number of mole of the inert gas at the input side. So first we can find the number of mole of the ethylene by using this general equation given. So the number of mole of ethylene at the final, which is at the output side, is equal to the number of mole of the ethylene at the input side, which is what we must find, minus extent of reaction 1. Because the species is react at the extent of reaction 1, and the ethylene is at reactant side. So when we calculate it, we get equation 1 as the final answer, which is we have two variables here. First, the number of mole of the ethylene, and second, the extent of reaction 1, which is we don't know what is the value. So second, we can find the number of mole of the H2O, which is the water, using the same method as how we find the number of mole of the ethylene. So the number of mole of the water at the output side, which is 100 mole multiplied by 0.466 mole H2O per mole, equal to the number of mole at the input side, which is what we must to find, and minus extent of reactant 1 plus extent of reactant 2. Why we minus and plus? Because first the H2O react at the first extent of reactant 1 as the reactant side, and second the H2O is react at the extent of reaction 2 at the product side. So we consider it as plus which is positive value. So when we calculate it, we get the second equation which contain three variable, which is the number of mole of the water at the input side, the extent of reaction 1 and the extent of reaction 2. Okay, for the from the previous calculation, we know that there are two variables we must to find before we can calculate the number of mole of the ethylene and the number of mole of the water. So the two variable that we must find is the extent of reaction 1 and the extent of reaction 2. So first species we can use to find the extent of reaction 2 is by using the ethyl ether species. So the number of mole of the diethyl ether at the output side, which is the 100 mole multiplied by 0.002 mole diethyl ether per mole, equal to the number of mole of the ethyl ether at the input side, which is 0 because the ethyl ether just act as a product in this reaction, plus extent of reaction 2 because the ethyl ether is as a product, so positive, and when we calculate it, we get the number of the value of extent of reaction 2 is 0.2 mole. So second thing to find is the value of extent of reaction 1. So when we analyze in this reaction, the second species we can use to find the extent of reaction 1 is by using the alcohol species. So the number of mole of the alcohol at the output side, at the output side, which is the 100 mole multiplied by 0.045 equal to the number of mole at the ethanol at the input side, which is 0 minus 2 multiplied by extent of reaction 2 because there are 2 mole of ethanol are used in extent of reaction 2 as the reactant, so we use negative value here, and plus extent of reaction 1 because at extent of reaction 1 the ethanol act as a product, which is we consider as a positive value. So when we calculate it, and we get this, and previously we get the value of extent of reactant 2, and when we insert into this equation, we get the value of extent of reaction 1 is 4.9 mole. So from the previous calculation, we get the value of extent of reaction 1 and also the value of extent of reaction 2. And now we can proceed our calculation by finding the number of mole of the ethylene and the number of mole of the water by insert both value into the equation 1 and the equation 2 from the previous slide. So the number of mole of the ethylene at the input side, when we calculate it, which is we insert extent of reaction 1 into the calculation, and we get the number of mole of ethylene is 42.3 mole. And from equation 2, we insert the extent of reaction 1, and we also insert the extent of reaction 2 into this calculation, and we get the number of mole of the water is 51.3 mole. And from the general knowledge, this we know that the extent of the value for the inert gas is 0, which is because the number of mole of the because the inert gas is non-reactive species, hence the input is equal to the output. So the number of mole of the inert gas at the input side is plus with 0 because it is a inert gas. At the output side, this is output and this is the extent of reaction. So the number of mole of the inert gas, we get the 11.3 mole. As the conclusion for this question, all the final answer for all the unknown variable that we find, which is that we calculate in this calculation, is the same whether we using a different calculation method, which is whether we using the atomic balances or using the extent of reaction method. And that's all from me. Thank you.